Welcome to The Explainer. Today, we're going to pull back the curtain on the medicines we all take. We're talking about the incredible digital world behind them, a journey that starts with just lines of code and ends with, well, a life-saving cure. So, what is it that turns a simple chemical into a life-saving medicine? It's a really fascinating question. And the answer? Well, it all comes down to a fundamental challenge, a problem that every single drug has to solve to even work inside your body. Okay, let's get right into it. Every single drug faces this huge dilemma once it's inside you. See, it has to do two things that are basically opposites. First, it's got to dissolve in water so it can travel through your bloodstream, but then it also has to pass through fat to get inside your cells where it does its work. It's kind of like it needs a bus ticket to ride the bloodstream highway, but it also needs a special key to unlock the fatty door of a cell. Two totally different jobs. And that's the real trick, right? These two things, being water-soluble and fat-soluble, are usually total opposites in chemistry. It's a real chemical tug of war. So the big question is, how do scientists design one tiny molecule that can do both? Well, it turns out they focus on one absolutely crucial property. You can think of it like a magic number that controls this whole balancing act. And that magic number is called the pK. I know, it sounds super technical, right? But stick with me. All it really is a number that tells us how likely a drug molecule is to pick up or lose an electrical charge when it's floating around in a solution. Like your blood. So here's why that charge is so important. When a drug molecule is charged, it absolutely loves water. It dissolves perfectly, and that's exactly what you want for it to travel easily through your bloodstream. But, and this is the cool part, when that same molecule is neutral, when it has no charge, that's when it can slip right through those fatty cell walls. It's almost like it puts on an invisibility cloak to get past the cell's security. You see, controlling whether a drug is charged or neutral is everything. It's the key to making sure it works. And that pKa, that magic number we were talking about, that is the master switch that flips the molecule between those two states. Okay, so how in the world do scientists figure out this magic number? I mean, in the old days, this would have taken months and months of tedious lab work for just one potential drug. But today, it's a completely different story. They do it in the cloud. And this change is, it's a total game changer. We've gone from painstakingly mixing chemicals in a lab to running incredibly powerful simulations on a computer. We can now predict how a molecule will behave before a single atom of it has even been created in the real world. So the modern process, it's just so powerful. What they do is they build a digital twin of a molecule. Let's take a common painkiller, like ibuprofen, for example. They create this perfect 3D model of it, and then they just feed it into the simulation. Then the computer does the heavy lifting. It crunches all these incredibly complex quantum chemistry equations, basically figuring out how the molecule will act in all sorts of different situations. And boom, in a tiny fraction of the time it would have taken in a lab, it spits out the answer. For ibuprofen, that magic number is 4.075. All right, so we have this number, 4.075. What does that actually mean for you when you pop an ibuprofen? How do we get from pixels on a screen to a pill that actually eases your headache? This is where it all clicks. It's beautiful, really. Because of that pKa of 4.075, when ibuprofen hits the superacidic environment of your stomach, it stays neutral. And remember, neutral means it can pass through fatty walls. So it gets absorbed right through your stomach lining, easy peasy. But then, the second it enters your bloodstream where the environment is way less acidic, bam, it instantly becomes charged. And charged means it dissolves in water, letting it travel all over your body to find that spot that's in pain. And that's the revolution right there. This power to predict how a drug will act just from a digital model is completely changing medicine. Scientists can design better drugs, safer drugs, and they can do it so much faster and cheaper. It just massively speeds up the whole process, from a simple idea to an actual cure you can hold in your hand. So yeah, the next time you take a pill, any pill, just think about that incredible digital journey it went on. It started out as a puzzle, got solved with a magic number that was figured out in the cloud, and ended up as a medicine that helps you. It really makes you think. The next great cure might not come from a test tube, but from a line of code.